Yes, see, in this universe, what are all the sensor or what are all the automatic things available in this world by the artificially made by the human is copied from either by the human activity or animal activity or from the nature. Okay, so the ultrasonic sensor from this slide, it is very clear to you who use this ultrasonic sound. There are plenty of animals using this ultrasonic sounds to live in this universe. So one of the example is the bat. So why bat uses ultrasonic sound to travel? Can anyone unmute and answer? Hello, why bat uses ultrasonic sound to travel? Hello, can anyone unmute and answer? Hello, hello, hello. Am I audible, students? Hello. Yes, okay. Can anyone unmute and answer why bat uses ultrasonic sound to travel? Hello, hello. Okay. Uh, Everyone know the answer, but I don't know why you are not replying because it doesn't have vision. Okay, that is the idea behind that. Wherever we don't have a vision, we need to sense some object without vision means we can use this ultrasonic sound as a one of the object. So here it's also doing the two things. It is going to produce the sound, and it is going to receive the echo based on the time distance between the sound and received time. It is going to calculate the distance of the object present in front of it. Okay, similarly the fish is also using this ultrasonic sound to detect the obstacles in the undersea water. The same working principle they used for the submarine vehicle. Okay, in submarine vehicle also to detect the obstacle inside under the sea water, they are using ultrasonic sound to detect the obstacles. So these are all the fundamental things. As sir told already, where we are using practically nowadays, automatic electric vehicle and autonomous vehicle is the very popular one. There we need a parking system. And also, once you start travel in the main road, you need to detect obstacle nearby you. So, the backside of your car bumper, you are having number of ultrasonic sensors. These sensors are used for parking system. Nowadays, in 360-degree angle of your car, you are having plenty of ultrasonic sensors. That is for your autonomous driving. Okay. So from this, it is clear that you have a plenty of application in the automobile field. The second one is the very important one. It is a biomedical field. You may aware of the ultrasonic sound, how they are using this one, and various stages to detect a particle inside our human body. Again, we are using the ultrasonic sound to detect a particle inside our human body. Okay, this is the application in the biomedical field. What I can do as a student, so you can use ultrasonic sensor to design any robotic car, autonomous car. Okay, you know how to run your car with the joystick. If you want to make the autonomous, you need to give the vision to your robotic car means simply you can put an ultrasonic sensor in front of your car. Okay, then in this pandemic situation, we aware of that automatic hand sanitizer is the one of the tool to sanitize our hands. There we are not encouraging any touch switches. So what we need to sense the presence of the hand. Once it senses, my dispenser need to give a drop of sanitizer, isn't it? So these are the few applications. In this pandemic situation, ultrasonic sensor used in the entire automation industries. So this is one of the example is the hand sanitizer. Then blind stick. Three or 2 years before, in our IIT contest name called Make in India Hackathon. In that, our students got second prize. This is the project got first prize. So this is the blind stick. The IIT Delhi student designed this blind stick. Even in our college, few students were did their mini projects also with this. See here, you may find the ultrasonic sensor. It is present in your blind stick. Whenever the blind person moves, they can detect the obstacle in front of them. Accordingly, they can change their track. So these are all the kind of projects you can do it with yourself. Okay. Then at last I will show one video regarding this application of your ultrasonic sensor. Ma'am, this video is visible in both the classes, ma'am? Hello, ma'am? Hello, ma'am? Okay. See. How they automated? What is the sensor present over there? Can anyone unmute and answer? Hello? How they automated this? What is the sensor present in this project? Can anyone unmute and answer? Hello?
Ultrasonic sensor.
Very good. See, here they placed ultrasonic sensor. Hereafter, we are not allowed to touch any material in the public places. So how to automate it? Very simple. Here you have one sensor. Here you have one actuator. Once the sensor senses the object present in front of it, it immediately triggers your actuator. Thereby, your actuator makes your output to work. Okay, so these are the few examples in this recent pandemic situation we received in the WhatsApp group. Okay, and at last I will show one, then immediately we'll go back to the lab. See, it's also coming under Make in India project. Can anyone tell what it is? That's all. Automatic Tirtha missing. So hereafter, you no need to contact with any metals. If you place your hand nearby that, here you have an ultrasonic sensor. Need not to be ultrasonic sensor. You can use any obstacle detection sensor. That may be IR sensor, okay, or any photo sensors. You can use it. But if you use ultrasonic sensor, it is little accurate than other sensors. Okay. So with this, we will enter into the today's lab session. So I'm going to Tinkercad. Is it my screen is visible? Is it my Tinkercad screen is visible in both the classes? Yes, ma'am. Okay, ma'am. So these are all only few applications we shown over here. You can do n number of projects with this. See, nowadays, if you open Tinkercad, the Tinkercad gives one new message that we added one new microcontroller with your Tinkercad. If you want to learn, you go and enter, go and try this one. This microbit. This is a Cortex ARM series controller is available in this board. If you want to learn yourself, you study and learn this one. Okay. Nowadays, it is newly added in your Tinkercad software. So for our project, what we need, we are going to fetch the Arduino board. It's a very simple experiment. Okay. What are all the things I need? I need Arduino board. Then I need on breadboard. Then I need on breadboard. Followed by only one component. It's very simple. It's my ultrasonic sensor. So as sir told already, we have two type of ultrasonic sensors. Where ultrasonic sensor will present, whether it is present in output component or input component. See, all the sensors falls under the input component. Go to input component. Here you may find two type of ultrasonic sensors. The one is the 3-pin sensor. Another is the 4-pin. We will finish with the 3-pin first, then we will come back to the 4th pin shortly. Okay. So as we discussed in our theory portion, the 3-pin ultrasonic sensor has two things. One is the transmitter, another one is the receiver. So you may find the eye like a component. One is the transmitter, another one is the receiver. So transmitter, with the help of transmitter, you are going to transmit your ultrasonic sound. Then using receiver, we are going to receive the ultrasonic sound from the environment. Okay, so this is regarding the component present in this one. Beyond that, you have controllers also in this. We are not going to discuss that. Then how to interface this? So as sir told already, we have 3 pins over here. So what are the 3 pins? Can anyone unmute and answer? What are the 3 pins present over here? The one is the ground. Then another one is the 5-volt or power pin. The third one is the signal pin. So what we need to do? First I need to give some square wave pulse to this signal pin. Thereby, transmitter will produce some burst of ultrasonic sound waves. After some time, I need to make the same pin as the input. Then I need to read the square wave signal. Okay, so that is the task. What we are going to do step by step. So if you want to learn further about the sensor, means you have a data sheet. We will circulate this data sheet to you. You can go through the data sheet thoroughly. Okay, then you can enhance the knowledge about this sensor much. Okay, here these are 3 pins available. So distance measurement already sir told to you. This sensor capable of measuring the distance between 2 centimeter to 3 meter. That is a one thing based on your application. As for the programmer, what I need to take it into mind means what is the operating voltage 5-volt I need to give. Then what is the triggering input I need to provide? So triggering input is nothing but a positive TTL logic I need to produce. What is the duration of the pulse? It may be 2 microsecond, minimum 2 microsecond I need to give. Typically they advise to use 5 microsecond. Okay, that's all. Then echo pulses, these are all the pulses we are going to receive it from the sensor. Okay, then the fabrication, this is the pulse we are going to generate. So very simple, I am going to generate 2 microsecond high pulse for some time. Then I will measure the signal from the same pin. Okay, initially it will be act as output pin, then I will change it as an input pin, then I will measure the duration of the pulse. Okay, here they given one more example in this data sheet as a water level measurement. See, using this ultrasonic sensor, you can measure the water level. So in your overhead tank, if you want to measure the water level in your tank, if you fit a pipe like this, you can measure the water level. Okay, these are all the some of the applications of your ultrasonic sensor. Now straight away we will go to the simulation mode. Bring the sensor, start, give the hardware connection as usual. 5-volt, 5-volt. Is it my screen is visible in both the classes? Yes, right. Dear students, is it Tinkercad screen is visible in both the classes? Hello? Hello? Okay. Yes. So ground pin, I am going to connect it into the ground pin. Hello? Yes, ground pin. Then 5-volt, straight away connected to 5-volt. Signal pin. So as we discussed in our example, let me use the same 7th pin as a signal pin. It is not mandatory all the time I need to use the 7th pin. I can use any one digital input output pin. That's all. Very simple connection. Only 3 pins are available. 3 pins are available. VCC and ground we have connected. The third one is a signal pin. Come to the code portion. So here we need to start type our code. See, step by step only we are entering into the program. I'm not going to show all the output in a single scratch. Okay, I'm going to make the pin number 7 by default. I'm going to make the pin number 7 as output, and followed by let me zoom it. Yes, followed by we are going to make the same pin into logic low. Okay, so this is the default value what we are going to give it to the pin. Okay, digital write off 7th pin, comma 0. Okay, so this is our signal pin. By default, I am going to keep it as an output. So whenever I want to give the trigger signal, it need to be act as the output pin. Whenever I need to receive the echo at the time, I need to change this mode into input. Okay, then let me delete the default coding. Okay, point number one. What we need to do, as we discussed earlier, as we discussed earlier, we need to generate one start pulse, isn't it? We need to generate the start pulse. Once you generate the start pulse, this trigger pin will see this transmitter will start transmit the ultrasonic sound. Then once it hits by any obstacle, it come back and it is received by the receiver as an echo. At that time, there will be a logic change in the same pin. Okay, what is the logic change? So once the ultrasonic wave is transmitted, the particular pin will be act as a logic high. Whenever it receives the echo, immediately that pin will goes to low. So I need to measure the high duration. What is the duration of the high pulse in the same pin? If I measure this timing duration, I can convert this into a distance value. Okay, that we will do it here. Okay, so first point number one, what we are going to do, we are going to make the particular digital pin as a logic high. Logic high. What is the duration? The duration is typical duration is given in the data sheet. The minimum I can keep it as a 2 microsecond. How we can create the delay 2 microsecond? Can anyone unmute and help me? Shall I use delay of 2? Is it right? Hello? Shall I use delay of 2?
So delay microsecond of 2.
Very good. Microsecond. Delay microseconds. Very good. So delay microseconds of 2, followed by I need to make the pin as logic low. That's all. That's all. So successfully we have created the start pulse. We have created the start pulse. Ultimately, what will happen if I give the signal to my system? If I give the signal to my system, here you have two components. One is the transmitter and another is the receiver. The transmitter will start sending the burst of, I think it's a eight pulses of ultrasonic sound. It will start transmit. And if I bring any obstacle nearby that, the receiver will receive the sound. Okay. So come back to the code. So here we have created the triggering pulse. The second thing is we need to measure the duration of the duration of high in the particular pin. So if we want to read the information, I need to change the pin configuration of the particular pin as input. Okay. Now I am going to change the same pin as input. That's all. Followed by the new syntax. What you have studied today is the pulse in command. Okay. So pulse in command. See, we go to your Arduino IDE, go to tools. So go to help. There you will find one section called reference. Okay. Go to Arduino IDE, go to help, then click reference. See, if you click the reference in offline mode itself, it will work. There you will find n number of functions what they are using in the Arduino IDE. Okay, whenever you start use any new functions, yourself you go and browse it. See, simply if you type Control F and if you type pulse, means it will automatically navigate to the section called advanced input and output. There you have the function name called pulse in. If you click the pulse in particular hyperlink, it will give the whole theory. See, you don't need much thing. Only the 2 lines are very, very important. Please read it once. See, what is the description of this particular command is reads a pulse on a pin. Okay, that pulse may be either high or low. That is point number 1. For example, if value is high, if you are using pulse in command means it waits for the pin to go to high. It waits for the pin to go to high and it starts timing. Then it waits for the pin to go to low, stops timing. Very simple. What it means, if I use the command as pulse in, the pin number followed by the value. See, pin number. This is the syntax, actual syntax what you need to use. Pulse in, pin number, comma, value means what it is going to do, it is going to read the value from the particular pin. Let me copy the same syntax and paste it over here. See, pulse in, what is the pin number? I am going to use the pin number as a 7. And what is the logic I am going to represent over here? High or low. So I am going to type it as a high. That means what? My controller will wait for the 7th pin to become high. That is point number 1. Then it waits and starts counting the time until the pin become low. When the pin will become low, whenever it receives the echo signal by the receiver, immediately it will become low. When it will become high, whenever you trigger the ultrasonic sensor and it starts sending the burst of signal, immediately the pin will become high. Okay, so once it is high, it will start measure the duration until its state changes from high to low. In case if I type the syntax as a low over here, it will wait for the pin to become low, then it will start count the time until my pin become high. It will start count the duration, then it will return the value. Okay, what is the value of the return value? See, it will be in microseconds. Okay, the value will be in microseconds. Somewhere they may mention in this description. Okay, you can see it will return the value in microseconds. Okay, so now what we are going to do, we are going to read the pulse in command value, and we are going to measure the high duration. Immediately we are going to store it in the variable. Here I can't use the integer as a variable, since it is a microseconds. It goes beyond the that data type I need to change, so I'm going to change it as a long. Okay, and what is the variable I can use? Let me use it as a duration. Okay, so long duration equal to pulse in of 7 comma high means the whatever the value measured by the particular function will be stored into the duration. Okay, so if you want to measure the, if you want to view your duration value, means you need to print the value. So how we can print the value? I need to initialize my serial monitor using the command called serial.begin 9600. Okay, then followed by serial.begin, then followed by I need to print the particular variable name. Okay, serial dot println of what is the duration? This is the calculated duration. Okay, that's all. First, what we will do, we will print this command and we will check the output whether we are getting duration or not. So if you want to realize the output value, means we need to introduce some delay between one command to the another one. Okay, see here, one more thing I need to do, my cycle need to repeat it again and again. Okay, so here I made the pin as the input. Okay, here I made the pin as the input, but whenever I come back over here, my pin I need to act as the output pin. Okay, you know why I need to change this as output one? Because in the initial time it need to generate a trigger signal, therefore I need to change the same pin number as output. Okay, then followed by the default value, what we are going to keep, followed by the default value, I'm going to keep it as a logic loop. Okay, now what we are going to do, I'm going to start simulate this one. Okay, start simulate this one, and just we are going to check whether we are getting change in duration or not. Okay, yes, see, if you click the sensor, here you will find one animation. This animation will allow you to change your obstacle in front of your sensor. Can anyone view this? This blue color dot. The blue color dot is your object present in front of your sensor. Okay, I can move the sensor. See, I can move the object and I can check whether my duration is changes or not. Over here, at present it is 9000. I'm changing little bit. Whether the duration varies or not, can anyone check? Whether the duration getting, see now duration need to get decrease because the distance between the object and sensor is getting reduced. Is it okay for everyone? Do you have a doubt so far? Please interrupt me. Else let me continue. Hello? See, if I move the object above, what will happen? Whether duration will increase or decrease. Can anyone unmute and answer? Hello?
It will increase, sir.
Will increase. Very good, ma. We will check it. Let me move the object. It's getting increases. Okay? That's all. Now, what is the second part we need to include in this? What is the second part? Remaining all the things are the calculation and conversion factor we need to do. That's all. Okay. So here we are getting the duration. Now I need to convert this duration into a what? Into a distance. So as I told already to you how to measure the distance. So how to measure the distance? So I need to multiply my duration with the velocity of the sound. Okay, then I need to divide it by 2. Since I am getting the duration microseconds, since I'm see if you have any doubt, see if you no need to memorize this value, go to Google. Okay, what is the speed of sound? If you are having any doubt with this, see if you type simply it will give 343 meter per second at 20 degrees Celsius at dry air. See this parameter also something related to your temperature. As I told already, it's like your Ohm's law. Here the speed is also depends on your temperature. At 20 degrees Celsius at dry air condition, this is the value. So this value only we are going to take. If you want to convert this into centimeter, means I need to multiply it with 100. Then I want to convert the second into microsecond, means I need to divide it with 10 exponential of 6. Okay, so that is the conversion what we are going to do it over here. So if you do those two conversions, the value will become, now we will do one thing, we will duration, now we are going to type it as a distance in centimeter. Okay, distance in centimeter. What is the conversion I need to do? I need to take this duration value, followed by I need to multiply with the velocity of the sound. What is that? 0.0343. Okay, then see this duration, this distance is nothing but a 2-1 flow motion. See, this is the sending time as well as the receiving time. Put together, it gives the value. But if I want to measure the distance, see, this is the same concept they are using for the satellite also. From the landing station to the satellite, if they measure the distance, they will give the twice of the distance between the transmitting value and the satellite. Ultimately, what they will do? They will divide it by 2. The same thing we are going to do it here. Divide it by 2. That's all. So thereby I am going to receive the distance in terms of centimeter. Okay. Now what we are going to do? We are going to print the value in centimeter and we are going to check it. Okay. So serial print of distance in centimeter. Serial print of distance in centimeter. So if I print like this, I may not know what is the quantity. So let me add the unit also. So serial dot print ln, within the double quote I am going to include the unit. So now what we are going to do? We are going to print only the distance in centimeter. So if you want to print the duration, let me add some variable name in front of it. Then we will start to print the duration equal to this much. Okay, this much microseconds. See, whatever the thing you want to add it in the print statement, that is your wish, you can add it. So print ln of, what is the distance in duration in microseconds. Okay, this is your choice, microsecond. Similarly, Similarly, distance in centimeter. Distance in centimeter. I think everyone can understand what we are typing over here. Okay, now we will check it. Let me start simulate this one and we will check the output. Yes, open the serial monitor. Yes. Okay. Now what we will do, we will open the animation panel and we will check it. Yes. Yes. Here our ultrasonic sensor is available. Yes. Wait a minute. Let me fit it to the screen perfectly. Yes. Bring the serial monitor. Bring the serial monitor. Yes. Is it serial monitor is visible? Is it serial monitor is visible? See, here distance is approximately 257.6 centimeter. How much we are getting? 252.40 centimeter. Okay. So what is the multiplication factor that we are doing? 0.032 microsecond. Let me keep it as a 4 and check it. Okay, so distance is equal to 254.27. The duration is this much microsecond. Let me change the distance and we will check the output value. Okay. Let me change the value. Let me keep the minimum value as 36 centimeter. Now here you check it 35.05. Almost we are getting the output value. Let me keep it here 200 centimeter over here. Here it is 195.11 centimeter. See, if you want to get the accurate value, you can alter your multiplication factor, then you will get the accurate distance. Okay, is it clear so far? Clear so far? If you want to check the distance alone, let me comment these lines. Yes, now you can check only the distance in centimeter. Okay. Okay, so this is the minimum value. Slowly I am increasing the obstacle distance. It's getting varies. That's all. So the last one, how to make the conversion. Here you are getting two measurements. One is in centimeter, another one is inch. How you can convert this one means it's very simple. It's very simple. Stop your simulation. Stop your simulation. You want to add one more thing for your inch conversion. So simply what I'm going to do, I'm going to add one more thing here, distance in inch. Okay, distance in inch. So it's a very simple formula. So distance. See, again, if you have a doubt regarding this, how to convert centimeter to inch. See, everything available in Google nowadays. See, if you want to convert 1 centimeter to inch means this is the multiplication factor. Okay, what I need to do, take the same multiplication factor, and multiply with the variable name called distance in centimeter. See how simple is this? Now we have converted this into inches. Okay, distance in inch, distance in inch. Distance in inch. That's it. Do you have a doubt so far? Please interrupt me. Else we will start simulate this one. Open the serial monitor. Open the serial monitor. Clear the serial monitor once. See, distance in centimeter is this much. Then distance in inch is this much. Okay. Now I am going to keep 33.3 inch. How much we are getting here? Check it. 32.47. So almost nearer to that. Then centimeter, here it is 84.6. Here it is 82.52. If you increase the distance and check it, 96 inch here, how much we are getting? Here it is 93.26. Centimeter is 236.8. Here it is 243. Okay. So likewise, you can design your ultrasonic sensor according to your application. Okay. So do you have any doubts so far? Please interrupt me. But in most of the cases, if you buy a component from the market, most of the time you will get 4-pin sensors only in the market. Okay. At that time, what are the modification we need to do? Go to component list. Do you have any doubts so far? Shall I continue? Hello? Hello?
Gajendran?
Sir?
கேட்டீங்களா?
சார் அதான் சார் ஏதாவது டவுட்ஸ் இருந்தா கேட்டேங்க சார். ஏன்னா அந்த 4-pin இது காட்டிடலான்னு பார்த்தேங்க சார்.
ஓகே.
It will take only 5 to 10 minutes to make the modification in this. See? Do you have any doubt? Shall I continue? Okay. So what we are going to do means, now we are going to replace this sensor. We are going to take the 4-pin sensor. See, 4-pin sensor, the functions are very much similar. Only one thing is the pin available in the particular hardware. See, here you have a separate pin for trigger, separate pin for echo. That's all. That means what? Trigger pin is meant for only triggering action. Echo pin is meant for only echo action. So we want to read further about the sensor. So this is the sensor model number HCSR04. So here, what are the small modifications here means, here the sensing distance. It's from 2 centimeter to 400 centimeter or 4 meter. Okay, there it is only maximum of 3 meter. That is the point number 1. Then point number 2 is, here IO trigger time duration is 10 microsecond. There it is 2 microsecond. Typical value is 2 microsecond. Okay. Beyond that, remain things are very much simple. So minimum range is 2 centimeter, maximum range is 4 meter. As per this sensor is concerned. So this is your transmitter. T means transmitter, R means receiver. So this will transmit, receiver will receive the output from the external environment. So you have a 4 pins. So what we are going to do, initially we are going to create this triggering pulse. Then immediately your transmitter will start generate your ultrasonic sound of 8 cycle. Then we need to measure the pulsing in pin. So the pulsing pin, this is the duration, this is the expected duration. If you measure this high level, you can find the duration. Okay, now we'll come back here. We'll make small hardware connections change in this circuit diagram. What are changes I need to make? So the first pin is VCC. The first pin is VCC. Okay, then ground pin. So ground pin. This is my ground pin. Then trigger and echo, I need to use separate pins. So trigger, let me use pin number 6 for trigger. Okay, pin number 6 for trigger, then 7 for same echo. Okay, so what are all the program modification we need to do? It's very simple. In initial stage itself, let me, if you want, you can declare the pin number int trigger. Okay, int trigger equal to what is the pin number we have given here? Trigger is pin number 6. Okay, then int echo. Echo means what is the pin number 7. That's all. Then followed by we need to declare the mode of operation. So trigger pin is always output here. Okay, the trigger pin is always output here. Then similarly, the echo pin is always input pin. So there we use the single pin. In between we changed the mode of operation where it is a fixed one. Okay, so this is trigger. Second one is the echo. Echo pin is going to act as a only input pin. Very simple. Then what are the other changes? So trigger pin by default we need to make it as a logic low. Okay, trigger pin I'm going to make it as a logic low. Then remaining things are very much similar. Only few concepts we need to change. Initially I need to make the triggering pulse. So I need to make the triggering pulse for the duration of 10 microseconds. For this sensor is concerned, the typical value is 10 microseconds. Followed by, I need to make the same pin as a logic low. Then, I no need to change the mode of operation. So let me delete this one. Duration. From where we need to check the duration? We need to check the duration from the pin number of trigger or echo. Can anyone unmute and answer? From where we need to measure this pulse in value, whether it is in trigger pin or echo pin. Hello? Can anyone unmute and answer? Hello? 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 From where I need to measure, whether from trigger pin or echo pin? Echo, very good. From the echo pin. Okay. From the echo pin, we are going to measure the duration we are going to measure it. Then followed by, we no need to make these changes and all. Let me delete this also. That's all. Very simple program. See, we are going to trigger the pin number 6. Then we are going to measure the echo. Followed by all the remaining calculations are similar to your previous one. Okay. Now we will start simulate this one and we will check the output. See, distance is here 113.4 centimeter. Here we are getting 110.35 inches, 43.44. Let me change the target distance and check it. How much we are getting? Now the distance is in centimeter is 291 and 114.58 inches. Okay. Here at last what we need to do, we need to add one more condition. As like your parking system, if my distance is greater than 250, I need to print it as a too far. Okay. Then if it is less than 50 centimeter, I need to print it as too close, or else I need to print it as normal. Okay. How we need to make this one? Close the serial monitor window. Come back here. Here we will, let me include the if else statement. Okay. If my distance in centimeter, where it is here. Here my distance in centimeter is, greater than 250. Okay, greater than 250. What I need to do? Simply I need to print it as serial.println of, what I need to type? Too far. Okay. Then what is the second condition? What is the second condition? What is the second condition? If it is less than 50 centimeter, 50 centimeter, what I need to type? Too close. Okay. Else what I need to type? Normal. Okay. Else what I need to type? Simply normal. So likewise, you can do a number of logical conditions. Even you can interface some buzzer according to the distance. You can make the change in sound in your buzzer value also, and do it. Okay. Now we are going to start simulate this condition. Yes.
Serial spelling mistake, Gajendran.
Open the serial monitor window. Clear the monitor once. Now it is showing normal. Normal also. Simulation. Open the serial monitor window. Keep the distance less than 50 centimeter. Too close. Can you see the output here? It is less than 50 centimeter. Therefore, it shows the value as too close. And let me keep it beyond 250 centimeter. It's too far. Okay. If I keep in between, it will give normal. That's all. So that's all regarding the ultrasonic sensor. I think some of the students they're using this as one of the sensor in their project. Understand the program. See, even if you refer from the internet, please go through the program, understand it with the help of the data sheet available in the internet, and then you implement it. Then only you can give some answer to the interviewer, or in future, if you want to teach to somebody else, you can teach. That's all from my side. If you have any doubt, you can ask me.
Gajendran, project என்ன பண்றாங்க ஒரு நிமிஷம் செக் பண்ணி Gajendran. Maybe you can leave them by 4.
Yes sir, yes sir. I think you people already bought the component, isn't it? நான் கொஞ்சம் interact பண்ணுங்க. I think you people already bought the component. You may finalize the component list also. What is the next step? Very simple. Take your laptop, install this Arduino IDE. Okay. Whatever the logic you are thinking, start type the coding in this IDE. Or else go to this Tinkercad simulation software itself. Fetch the sensors available. What are the sensors available? Plenty of sensors available. You may not check those sensors. Regarding your project input, let me give one more. Let me show one more presentation also regarding your project. We plan to. Yes. What is your project? See, the Tinkercad consists of n number of sensors. See, you can on off motor control. Whoever using robotic control, you can simulate. Then you can do your project. So you have some driver ICs also available in this. Then servo motor, position control. If you are doing, you can use a servo motor. Then IR transmitter and receiver. This is the wireless medium. This is also one of the hot needed one. See, here we are not going to touch the component. Only the users need to have an individual remote. If you have, you can control this much appliances in your room. See, three How many threes? 1, 2, 3, 4, 5, 6, 7. 21 components you can actuate it using this remote. Okay. See, these are all the components required for this project. Only one IR receiver, one transmitter remote, then your Arduino board already you have it in your hand. Okay. Using that you can do n number of projects. Okay. Then motor. See, whoever doing the that robotic control or something else, you have a DC motor in this Tinkercad simulation also. You can do the simulation, then you can implement it. Then 7-segment display also available. See, this is the one of the project we did for in the summer class. We did see water level controller testing project. So here we used ultrasonic sensor, LCD display, then your pump motor. So in our home domestic appliances, we are going to measure the overhead tank water level. According to the level of the overhead tank, we'll make the pump motor to on, isn't it? So this project we implemented using Tinkercad only. Simply you simulate it, immediately go back to your hardware component. See, the nowadays the current scenario is whatever the application the customer needs only in the form of app. How to create the app? See, if you have a Bluetooth, if you have Arduino board, if you have a smartphone, it is hardly will take 30 minutes to create an app. See, this is one of the water level indicator project. Even this kind of project you can do it. Whatever the sensor you are using, fetch the information to your smartphone and create your required dashboard. Immediately it will come. You have one wonderful tool called MIT App Inventor. Using that, you can do wonderful app project in your system. Okay, so these are all the few inputs we supposed to share regarding your project. The Tinkercad supports plenty of components, ultrasonic sensors, LDR, you know. Okay, then what are the other components? Go and browse it. See, by the time we doing the course, they added one more hardware component also in this. Okay, it is up to you. It is up to you. See, PIR sensor available, tilt sensor available. Whoever doing any accident detection or collision detection, you can use what? You can use this tilt sensor. Okay, likewise you have a n number of sensors here. Gas sensor, who are doing home automation, get the gas sensor, sense with the any one gas. If it is abnormal condition, give some alarm, give some LCD display. Like that you can do. See, keypad. See, where we can use the keypad. If anyone want to do any automation, if you want number, if user need to give some input, means the touch screen is the wonderful one. It will act as a both input and output. But the keypad is the typical simple input after your switch. See here how many buttons are there? 4 into 4, 16. So 16 appliances you can control. 16 appliances you can program it by your own. See, Friday, this time my ceiling fan need to turn on. You can design it. So plenty of things are available. Whenever you think about your project, you type it in Google. I think everyone can view the window over here. See, say example, you are using home automation. Like that, if you type home automation, immediately the Arduino will come in front of it. See, the fourth line, what you are observing, home automation using Arduino, home automation using Raspberry Pi, home automation using IoT. See, the beyond our class content, you have a plenty of forum to learn the concept, try to implement it. I think by this weekend you can finish your partial project output and you will make some video, or you can make something related to that. You can circulate to us. Let me verify that one. Then you can finish your project by the next week. So before CA3, you must show your project output as a video. Yes, sir. Sir, is it okay, sir? Yes, sir. See, here you have a number of components. Oscilloscope available, timer available. Go through it. If you have any doubt in this, you can ask us. Okay. Can a project without doubts irka? The Arduino எப்படி செக் பண்ணனும் சொல்லிட்டேன். Go to Arduino IDE, go to help, go to reference. Please make note of these root ones. Here you will find n number of functions available in your Arduino IDE. What are the new function you will start using? Click the particular function, learn it, then start to use it. Okay, ma'am. Hello, ma'am. Okay, ma'am. Can I this week try to finish